Hi there, everyone. I'm meteorologist Steve Pelletieri, and I am the Weatherman. Thank you for tuning into my latest weather episode, my podcast, and today we're going to talk about the upcoming beginning of summer, both the June 1st beginning of meteorological summer and that astronomical summer solstice beginning on the 20th of June. Also, the prediction from the NOAA is out for the upcoming 2020 hurricane season, and we'll explore the predictions by NOAA for the Atlantic and the Central and East Pacific. We'll also talk about that first tropical system of the season, along with other storms around the globe. As mentioned, the first tropical systems of the season developed just off the Florida and Georgia coast and traveled up along and parallel to the eastern seaboard. The first one was named Arthur, moved over the outer banks of North Carolina with some hefty rains, but only maximum winds of 50 miles per hour and close to the center. The second storm was called Tropical Storm Bertha, and the system continued to develop just off the Florida coast and then got absorbed into the mid-Atlantic states and basically just became a weather maker for the eastern and northeastern seaboard. So that system's gone down. We've got two in the books already so far for this 2020 hurricane season. But back to the hurricane season, however, more importantly, upcoming hurricane season of 2020, the National Hurricane Center did issue a forecast. And the report on that Thursday, the 21st day of May, forecasted a busy Atlantic hurricane season. And it's predicted for this year into at least the middle of the autumn season. Multiple climate factors indicate above normal activity is most likely. And the Weather Service expects an above normal 2020 Atlantic hurricane season. This is a prediction according to the forecasters at the Climate Prediction Center. And that's a division of the National Weather Service up in College Park, Maryland. The outlook predicts a 60% chance of an above normal season, with 30% chance of a near normal season, and only a 10% chance of a below normal season. So if you're a betting person, you'd have to say it's going to be either a normal to above normal hurricane season. And you're adding up those percentages of 60 to 30%, and it comes up to a total of 90. So 9/10, so 90% probability that above normal to normal hurricane season is upcoming for this upcoming summer and fall. So again, what the National Weather Service is saying, the percentage particulars there, forecasting a range of 13 to 19 named storms. We've got two already. And a named storm is those with winds of 39 miles per hour or higher, a tropical storm. And 6 to 10 of those, 13 to 19 storms, could become hurricanes. And again, as we mentioned, hurricanes of winds of 74 miles per hour or higher. Most importantly, the Climate Prediction Center includes the chance of 3 to 6 major hurricanes, and that's a Category 3 to a Category 4 or 5, with those winds of 111 miles per hour or higher. So that's gives us a percentage of up to 70% confidence that they're going to see that, at least that 3 to 6 major hurricanes, and a few of them 3 to 5 category storms. And it's going to be pretty bad. That's pretty impressive if you're significantly giving that we have that 90% probability of a near normal to above normal hurricane season with only that 10% chance of a below normal season. Their confidence is 70% of the time. And time will tell if they are right, and we'll be following it through the summertime. So we've already had Arthur and Bertha. And the next names that's going to be going is Cristobal, Dolly, Eduardo, Faye, Gonzalo, Hannah, Isaias, Josephine, Kyle, all the way up to Wilfred. Hopefully we don't get there. But unfortunately, if you're saying we're going to get up to 19 storms, that means we're going to get all the way up to the storms named Teddy. And the last three being Teddy, Vicky, and Wilfred. So what's in the name and how strong the storms become and whether or not they reach populated areas, the National Weather Center has some new tools this year as the season gets underway. You're going to begin feeding data from the Cosmic 2 satellites into some of those weather models to help track the hurricane's intensity and boost forecast accuracy. So they're using new satellites. And the Cosmic 2 satellites provide data about air temperature and pressure, humidity in the tropical regions of the Earth. And of course, as you all know, this is precisely where the hurricane and tropical storm systems mostly form. Also, during the 2020 hurricane season, NOAA and the U.S. Navy will deploy a fleet of autonomous diving hurricane gliders going into the ocean to observe conditions in the tropical Atlantic Ocean and Caribbean Sea, in areas where hurricanes have historically traveled and intensified. So with the hurricane hunters from Alabama, and now the Navy's autonomous diving hurricane gliders going into the sea, you're going to see from above and on and then below all these hurricane formations so we can get a better idea of how this is going to work out. That's a pretty big improvement. It's becoming more dimensional, up, at, and below, and hopefully we'll come up with some good models to predict accurately the track and intensity of these upcoming storms. Now, in the Eastern Pacific, the 2020 Eastern Pacific hurricane season outlook has a little more uncertainty to deal with. Number one, predicting El Nino and La Nina is close, and also called the ENSO, and it impacts ongoing scientific challenge facing climate scientists today. There is uncertainty as to whether the Eastern Pacific remains a high activity area during 2020, or if it's shifted to a low activity area. The prediction of combined impacts associated with the Pacific Oscillation and the Atlantic Oscillation remains a challenge as well. And those are factors that they take into consideration when they make forecasts for the Eastern Pacific. The ocean oscillations are generally defined as irregular fluctuations of atmospheric pressure over the oceans. It has a strong effect on weather conditions, and in close-by land areas, it also has a major effect. These oscillations could occur on a yearly basis, or the fluctuations can take place decades apart. It's an oscillation of change, up and down. When something oscillates, it goes back and forth, up and down. Because of the change in the atmospheric pressure, essentially a back and forth switching between two prevailing patterns. Now, a positive mode in oscillation, in ocean oscillations, is when a strong subtropical high is located over the tropical area. So positive is a strong high. And that's usually located between 10 to 20 degrees above or below the equator. A strong low-level pressure system runs to the negative mode, which could occur in those areas as well. So in summing it up, it's the oscillation or switching that results in a net climate change. So, and I know this is tough to follow, but when we have competing phases, oscillations in the oceans, the variation of developed named storms and hurricanes can occur. These weather patterns or oscillations are unpredictable on a seasonable time scale. They sometimes develop and last for weeks or at times months, then affecting seasonal hurricane activity. So with all this mumbo jumbo in mind, in the Pacific, NOAA predicts a 40% chance of a near normal season and a 35% chance of a below normal season. So going back to the same type of attitude that you have for the Atlantic, 40 and 35, 75% chance of an at or below normal season, and only a 25% chance of an above normal season. Again, this is in the Eastern Pacific. And they call for the possibility of 11 to 18 named storms, 5 to 10 hurricanes, including 1 to 5 major hurricanes. So that's the Eastern Pacific. And if you're planning to go out to Hawaii, all these great airfares and low prices despite the COVID concerns, may not be a bad idea. In the Central Pacific, centered right around Hawaii, there is a near to below normal 2020 hurricane season forecasted again. Again, that's a prediction from the Central Pacific from the National Hurricane Center. Pretty much, that's quite an interesting forecast. Above normal Atlantic season, a near to below normal Eastern Pacific, and a near to below normal Central Pacific hurricane season. So they're running the full gamut. They're a very active Atlantic, more of a quiet, normal to quiet Pacific type of situation. They only give a 25% chance of above normal seasons for the Pacific Ocean. And as a whole, again, that is going to be boding well, but unfortunately they usually produce a lot of rainfall for the desert Southwest, and including southern California. So with that in mind, drought-worthy dry conditions could continue there as well. So that trip to Hawaii should be pretty good this year. At least hurricanes may not be a big factor there. So there you have it. Above normal Atlantic hurricane season, near to above probability of 90%. 90%, that's really an impressive number. Then a near normal Eastern Pacific and Central Pacific season during the 2020. And so then again, just another thing to worry about these days in the pandemic and social distancing and fear of catching the bug. In the Atlantic and the Caribbean, Florida and the Gulf Coast, Eastern Seaboard, and of course the Northeast, there are significant population centers. For example, in New York, New Jersey, D.C. to Boston area is a megapolis. And that area not separated by states, but identified by its high population density. With 8.5 million people in New Jersey, close to 9 million people in New York City alone, not to mention the high population density of Boston, Hartford, New Haven, Bridgeport, Philadelphia, Baltimore, and D.C. A major hit by a storm or hurricane in those areas that I just mentioned, even with the weaker storms, tend to be catastrophic and very expensive. Not to say that I'm minimizing the effect of a direct hit of a major hurricane over Florida or the Gulf Coast, but the Atlantic Basin is an important area of consideration when predicting, tracking, and preparing for tropical systems. Let's hope for the best. Hoping for the best, in my mind, that would be hoping for a normal hurricane season and most of the hurricanes offshore and away from land areas. Might be asking a bit much, but you can always hope. Am I right? But on to summer. Meteorological summer begins June 1st Now, what does that mean? Well, on an average, the sun rises pretty early in the morning on the first day of June and sets pretty late in the evening on that date. The sun's angle is high in the sky, and you have a significant amount of daylight and a short period of nighttime. What happens during the day when you have sunshine? The temperatures go up. Therefore, your average temperatures just normally has to go up because of the extra added sunshine. On the other hand, at night, temperatures generally fall. A short period of nighttime means the temperatures decline is a minimum as well. Just doesn't have the time to fall. So your average temperatures are greater meteorologically around June 1st, lasting for the next 3 months. Actually, the meteorological seasons happen a little bit before each of what we call astronomical summer. For that reason, meteorologists break the seasons down into groupings of 3 months based on the annual temperature cycle, as well as the calendar. We generally think of the winters as being the coldest time of year, summer the warmest, with the spring and fall being the transitional phase. That is what the meteorological seasons are based on. Meteorological spring includes March, April, May. And that's what we're coming out of now, and it was a cool one. June, July, and August, meteorological summer. September, October, November are fall, and the start of winter is December 1st and lasts through the months of January and February. You might ask, why did they create these seasons? Well, is it not enough to have the 20th or 22nd day of the month of December, March, June, and September to call out the seasons? Well, it was weather observing and forecasting that led to the creation of these seasons, and they're more closely tied to our monthly civil calendar than the astronomical seasons. Instead of the 20th, you start with the 1st. It's easier to use the beginning of a 3-month period than the 20th or the 22nd, as mentioned, as an arbitrary month. Both represent 90 days of winter, 92 days of spring and summer, followed by about the same for autumn, so it makes sense to have meteorological seasons. But everyone loves that astronomical change. That brings us to astronomical seasons. Our next astronomical season is going to be on Saturday, June 20th at 5:44 p.m. Eastern Daylight Time. People have used observable period natural phenomena to mark the time for thousands of years. Stonehenge in Britain is the most notable ancient season clock. The natural rotation of the Earth around the sun forms a basis for the astronomical calendar, which we define the seasons with 2 solstices and 2 equinoxes. Solstice being a high and low point, and the equinox being that halfway mark. The Earth's tilt and the sun's alignment over the equator determine both the solstices and the equinoxes. The equinoxes mark the time when the sun passes directly above the equator in the northern hemisphere, and the summer solstice falls on around June 20th, and the winter solstice around December 21st. The vernal or spring equinox, the autumnal equinox, they fall around March 21st and September 21st, 22nd for the fall. And these seasons are reversed, but represent the halfway mark, as I mentioned, between the solstices. And the southern hemisphere, if you are going to South America or Australia, just to name a few populated southern hemispheric areas, all seasons are reversed, but on the same dates and times. Now, many folks wonder why we have to have a leap year as we've had this year. It's because the Earth actually travels around the sun in 365 and a quarter days. So an extra day is needed every 4th year, creating what we call a leap year day. This also causes the exact date of the solstices and the equinoxes to vary. Additionally, the elliptical shape of the Earth's orbit around the sun, it's not a circle, it's an ellipse, causes the length of astronomical seasons to vary between 89 and 93 days. These variations in season length and season start would make it exceedingly difficult to consistently compare climatological statistics for a particular season from one year to the next. Thus, the meteorological seasons were born. So let's explore the average temperatures and rainfall in the Northeast during the beginning, middle, and end of summer. I'm going to use the data from the Central Park, New York City, and the reason I'm doing that is because they have the data that goes back to 1869 to present. And if you're north of New York City, you're going to be a little bit cooler. If you're down in Philly, Baltimore, and D.C., it's going to be warmer. If you're in the interior, inland, you tend to be a little bit cooler sometimes because of less urbanization. And along most of the coastal areas, the temperatures tend to be a little bit less extreme because of the ocean influences. That being said, you'll find the data of Central Park, New York City being from the year 1869 to the present, 2020, and in any given June, as an average, it will post a high temperature of about 79 degrees. Then again, an average minimum or low temperature for June in New York City is 64. High of 79 for June, low of 64. So that makes the month average close to about 71 to 72 degrees. Here are some extremes. The coldest average June that New York City ever had was 64.2 back in 1903. The warmest average was not recently, but back during the war years of 1943. That year, the average temperature was 76 degrees. That's a whole 12 degrees above normal. 12 degrees above normal during the war years of 1943. Moving on to July, the New York City normal high is about 84 degrees. The normal low is 69. The average pretty close to July and August are about the same, 76 to 77 degrees. July is the average warmest month in New York City, and your extremes for the month of July shows an average of 71 degrees in 1888. That was the coldest. That was the year of the blizzard of 88 in March, with the warmest in 1999 coming in at 81.4 degrees. You can see there's a span of over 100 years between the coldest and the warmest. And in 1999, the warmest was just before that big change to the year 2000. The month of August, as mentioned, is about the same as in New York City as in July, temperature-wise. The average high temperature is 83 degrees, and the average low is 68. It's a little bit cooler, as the days in daylight in August are starting to get a little bit shorter. The coldest August was 69 degrees in 1927, with the average temperature of 69 degrees. 69 degrees, the average in 1927. The warmest of 80 degrees, that occurred in 1980. That August was the best example of the dog days of summer, and I'll cover in future reports. Now let's go to precipitation. Every one of the summer months is pretty much about the same rainfall-wise, but the difference is that the way you get the rainfall, it varies. I mean, the actual low pressure can move into an area and out of an area usually on the fringes of the seasons, beginning and the end, late May, early June. Storms come in from the southwest and along the coast. And as you head towards the end of August, similar situations start to develop. However, most of the time in the months of June, July, and August, especially late June, all of July, and early to mid-August, much of your rainfall comes from thunderstorm activity, which is a result of daily heating and the availability of moisture. Moisture availability and frontal systems moving through can also cause some severe weather. June's average rainfall is 4.4 inches. July is 4.6 inches. In August, you think you have a little bit more rainfall? It doesn't vary by much. The average rainfall for August is 4.5 inches of rain for the whole 31 days. When we're considering New York Central Park data from 1869 to present, the wettest of the summer months comes in at number one was 18.95 inches in 1 month. That was in August 2011. But the second highest, you have to go back to the 1800s. That was September 1882. Now, September not being really a meteorological summer month, however, I just thought I'd mention that the driest months of summer was just 0.7 of 1 inch, or practically nothing. That was in June of 1949. Then in August 1995, only about 2.2 of an inch of rainfall was recorded in August 1995. In August 1964, part of that great drought of the 1960s, only 1/4 of an inch fell during that month of August. And you can see by the range of total rainfall for any given summer can vary from practically nothing to 5 months worth of normal rainfall in just 1 month. That was that 18-inch figure that I mentioned. Usually the reason for the extreme range of thunderstorms is thunderstorms or tropical systems. And the reasons for the dry amounts of rain are many and are not completely understood. The most extreme drought, the drought of record, is the one that extended from 1962 to 1966 in New York City. I remember the commercial they used to have on the radio. Save water while there's water to save. Well, sorry about the singing, but that was basically the whole thing that kept going on for a few years. The reason that the drought occurred and the character of the drought, including the causes and the predictability, were largely unknown to this day. It's a good reason to have a paper, or at least to do some research, especially with all the improved research techniques that we have and computer power. We know that the 1960s drought was one of the most severe of the last few centuries. Longer, less extreme droughts had occurred in prior centuries, like the 17th and 18th century, verified by historical writings and analysis of tree trunk rings. Additionally, much has been said about the sea surface temperature, often referred to as the SST, off the Jersey and Long Island and New England coast. The SST would seem to be a factor as it was cooler than normal during those times when we had drought, which may have something to do with the astronomical factors, meteorological factors, or even ocean current factors. But when the East Coast SST is cooler, there tends to be less rain, and actually that makes sense. In order to have evaporation, you need warmth. Therefore, easier evaporation occurs when the water is warm. Like when you boil water and it boils out, it evaporates from a liquid to a gas called water vapor. So when the ocean is cooler, there's less evaporation to go into the atmosphere as water vapor, less to make clouds and less to make rain, resulting in those dry conditions. On the other side of the coin, tremendous rainfall could be caused by severe thunderstorms, many of them in the summer months. Then one coastal storm like tropical systems that can cause rainy periods of time and extreme amounts in any month of rainfall during those hurricane season months. Hurricane Irene caused over 11 inches of rain in a 24-hour period in many spots. That was the same with Hurricane Floyd of recent history in the northeast U.S. So the problem is that the averages are products of extremes and not the type of weather every year. You can go from a very wet summer to a very dry summer just in 365 days. Predicting what's going to happen means you have to throw in some extremes. You have to consider the normals, and you have to investigate for the possibility of the cooler and drier weather trends for summer mentioned above, meaning the SST or the sea surface temperature. So what does it all mean for this summer of 2020 upcoming? There is a forecast out. The official outlook from the National Weather Service, NOAA, for the month of June, July, and August 2020 is they are forecasting above normal temperatures for eastern New York and much of New England. Slightly above normal temperatures for New York City and New Jersey, near normal conditions for the Ohio and Tennessee Valley, and slightly below normal conditions temperature-wise in the Midwest and Northern Plains. Interestingly enough, though, they're predicting above normal conditions for central and southern Alaska, but near normal weather conditions across the North Slope near Prudhoe Bay. Precipitation-wise, the National Weather Service is predicting slightly above normal conditions for New York, New Jersey area. Above normal from Virginia down through Florida, west to the central Mississippi River Valley, near normal over Texas to the northern plains. And they give an equal chance of normal over desert southwest of California and Arizona and New Mexico. And above normal rainfall is forecasted for Alaska. Well below normal rainfall is expected over western Washington State, Idaho, western Montana, and a good portion of Oregon. So those places are going to be the dry areas. Summing it all up, near normal conditions for our areas to slightly above temperature-wise and near normal rainfall for the northeast corridor. I'm seeing NOAA forecasting typical to slightly above normal conditions for the northeast this upcoming summer season. What factors will change that? It was interesting to see some of those satellite pictures and daily sequences of pictures of pollution across the Northeast during the COVID shutdown during the months of March, April, and May 2020. Now, compared to normal years, like every year except 2020, the New York, New Jersey, Philadelphia, Boston, D.C. metro areas saw less pollution. Also, interestingly enough, temperatures during those months, March, April, and May, in those areas just mentioned were below normal, as was rainfall. Will this have a factor in our summer weather? Well, it remains to be seen. I don't think we're going to see an opening of the economy to full guns as we get into the months of June and July and August. However, it's going to be a tiptoe into that season with social distancing, staying safe for at least the next 3 to 6 months. That may have something to do with the weather we receive in the coming future. Just a little more information on the National Weather Service Climate Prediction Center. They actually make 3-month forecast all the way out to June, July, and August of 2021, a whole year ahead. Now, I know obviously these people do great work and work very hard. The computer models and algorithms that they use are quite complex, but to accurately be able to forecast trends over a period beyond 3 to 6 months to me seems a little aggressive. Just so you know, in 2021, the Climate Center is forecasting above normal temperatures from Maine all the way down to the Gulf Coast, westward to California for the summer of 2021, with near to above normal rainfall. I don't know about that prediction. Given a lot of these models work on trends, if our trends over the next 3 months to next 6 months do not pan out, what the computer models are expecting, they're going to have to reevaluate and recalculate. I think the confidence of them being able to pull off a 1-year forecast of summer conditions is probably less than 10%. Again, I'm not being critical. I'm just saying if they can really do this, it would really be a great benefit to society. And if only life were that simple. If only I didn't have to keep searching for toilet paper, gloves, and these funky masks that I see on everyone now being seen discarded everywhere, not in the trash basins. Put your stuff in the trash basins. What brings me to my last comments about the weather, summertime, and COVID-19. Keeping in mind the worst outbreaks of COVID-19 have been in the colder parts of the northern hemisphere during the winter and early spring. The big question is, will warmer weather slow the transmission? Some recent comments by the CDC and other experts are saying that the transmission of the disease by touching things is less than we thought. We get into summertime and possibly the COVID pandemic will be interrupted by the summer heat, like the seasonal flu is. Also, importantly, could the southern hemisphere see outbreaks intensify as that part of the globe now moves into winter? There are several reasons that more experts have opined that the virus will tend to disintegrate easier in the heat because of an oil-based shell. Dr. Oz made the statement about that a couple of months ago in the beginning of the pandemic, but there are a number of other factors that contribute to why the flu or any virus arrives in the winter. Winter is a time that a drop in the amount of water vapor is most evident in the atmosphere. Cold air makes it easier for the viruses to become airborne. In other words, the hazy, hot, and humid weather days of summer squeeze out the space in the air in the atmosphere. There is more water vapor forcing the virus to travel in the form of droplets. When you cough or sneeze or even talk, you generate those droplets that are coming out of your mouth. And if you're infected, the air is cold and dry, the virus transmits easily. That's their opinion. I'm just telling you what their theory is on this. But if the air is humid and hot, it either breaks down or just gets caught up in the water vapor. Check with your doctor about the concerns of virus transmission during the winter and summer. But in the meantime, it remains to be seen if COVID is going to be the same during the upcoming summer. Let's hope this COVID-19 dies and goes away. Let's keep socially distanced, wear a mask and when and where required, but try to go about your normal life as we get into summertime. If you're sick, stay home and get tested. If your fever comes up, call your doctor. Do all the things suggested by the professionals. Like I said in earlier podcasts, I believe in professionals. Go with the best. I guess we can't say enough about that. It's not the first time a global pandemic has happened, but because we are socially close, both with the internet and right up to this point where the flu started, we were hugging and shaking hands and getting real close to one another. Now we're going to have to change 180 degrees. We hope we can go from this pandemic 180 degrees to a normal life, if anyone remembers what normal life was. I'd like to thank you for listening. Hope you enjoyed or were informed by the summer weather and hurricane information in this podcast, and I'll talk to you next time. I'm certified consultant meteorologist Steve Pelletieri, and I am the Weatherman. Be well, stay safe, have a great summer.